Hello, good day everyone. So today we will be discussing factoring simple special product. Okay, so before we proceed to our lesson proper, let us review first the types of polynomials. So this is just a quick review. So we have here the types of polynomials according to the number of terms. So first is the monomial. So a monomial is a polynomial which consists of one term. For example, we have 6. Next, we have 4x minus 3. Then, for binomials, it is a polynomial consists of two terms. So, for example, 6x plus 2. So, our first term here is 6x. Then, our second term here is 2. Then, next, we have a times exponent of 4 minus 5, where our first term here is a times the exponent of 4. Then our second term is 5. Okay, next we proceed to trinomials. So a trinomials consists of three terms. So for example, we have 3x squared minus 5x plus 8. Our first term is 3x squared. Our second term is 5x. And our third term is 8. So this is what we call trinomials. It consists of three terms. Next, let's proceed to polynomials. So a polynomials when it consists more than three terms. Okay, so for example, we have here 2x cubed minus 6x squared minus 5x plus 8, where our first term is 2x cubed, our second term is 6x squared, our third term is 5x, and last term is 8, or the fourth term is 8. Okay, so when it has more than three terms, we call this polynomials. Next, let's proceed to the types of polynomials according to the degree of exponent. So when we say degree, that is the highest number of exponent a variable have. So for example, constant polynomial. So why is it that constant polynomial has 0 degree? Because we don't have a variable in here. So therefore, the exponent is 0. Next, let's proceed to a linear polynomial with degree 1. So our variable here is x. Also, in the second example, our variable is x. Then, let's take a look at the exponent of this variable. So, their exponent is 1 and also 1. So, we don't usually put 1 as an exponent because it is understandable that the exponent is 1. Okay, next, let's proceed to the quadratic polynomial with degree of 2. So the highest degree of exponent in the variable must be 2. So we take a look at with the variables. So which has the highest exponent? 1 or 2? So of course we take the highest degree. So therefore it is a second degree of polynomial. Next, we have here 5y squared minus 1/4. So we take a look with the variable y and look at the exponent. So the exponent is 2. So therefore, it is a polynomial with degree of 2. Okay, last we have the cubic polynomial with degree 3. Okay, so of course, the highest degree in here and the variable is 3. So we have here x cubed, 5x cubed, and the variable x with the degree of 3. Next, 2y cubed minus y plus 4. So the highest degree here is 3, or the highest exponent here is 3. That's why this is what we call the cubic polynomial with degree of 3. Okay, so this is just a review. Now let's proceed to our topic. Okay, so let's start factoring common monomial. A polynomial is said to be factored completely when it is written as a product of its prime factors. So when we say prime factors, the factors of this number is 1 and the number itself. For example, 3 is a prime number because the only numbers or the only factors of 3 is 1 and the number itself, which is 3. Okay, so for example, determine the common monomial factor of number 1 example. We have 15x squared plus 5x. So let us determine step 1. Get the greatest common monomial factor between 15x squared and 5xy. So start with 15 and 5. Find the number that is the greatest, or you look for the greatest number that can divide 5 and 15 without any remainder. So the answer is 5. So 5 is the greatest common monomial factor. So when you divide 5 from 15 and 5, there is no remainder. Okay, next. Then we find the common monomial factor for x squared and xy. So try to look at these terms. What is the common variable among these two terms? Of course, that is x. So x is the common monomial factor. The common variable between x squared and xy is the variable x because both term has a variable x. So try to look at x squared and xy again. So both terms have x as a variable and use the variable that has less value of exponent. So we get the variable that has a less value of exponent. So the value of exponent of x here is 2. And in the variable x and the other term, the value of exponent is 1. So we take the less number of exponent or the less value of exponent, which is 1. So only our common monomial factor is x, not x squared, because we need to take the less value of exponent. Okay, so for the step 2, get the remaining factor by dividing the common monomial factor to the given. So again, our given is 15x squared plus 5x, and earlier we solved for the 5x, which is our common monomial factor. So let us divide this common monomial factor from our given. So we have here 15x squared, that is from the given 15x squared. Then we have our 5x, which is our common monomial factor. So we just simply divide 15x squared divided by 5x. So 15 divided by 5, that is 3. Then x squared divided by x, so we have 1x remaining. That is, so the answer is 3 times x, so we have 3x. Okay, next. Let's divide 5x from 5xy. 5xy divided by 15x, so the answer is equal to y. So 5 divided by 5, that is 1. X divided by x, that is 1. So y is the remaining, so we have y. So our final answer is 5x times the quantity of 3x plus y. So this is now the factored form of 15x squared plus 5xy. Okay, so let's proceed to our second example, which is 6x squared plus 8x. So think of a greatest number that can divide 6 and 8 without any remainder. And of course, for our variable, x squared and x, so what is the common variable between them? And you take the less value of exponent. So the answer is 2x. So our common monomial factor is 2x because 2 can divide 6 and 2 can divide 8 also without a remainder. And for our variable, we take x because x is the common between x squared and x, and you take the less value of exponent. So the value of exponent of x here is 1. Okay, so that's why we take x. Okay, now let's divide 2x from 6x squared. So 6x squared divided by 2x. So 6 divided by 2, the answer is 3. Then x squared divided by x. So we have here a remaining 1x. So the answer is x. So final is 3x. Next, let's proceed to 2x divided by, or we get 2x from 8x. So 8x divided by 2x. So the answer is 8 divided by 2, that is 4. X divided by x, that is 1. So 4 times 1 is 4. So let's copy these answers to make our final factored form. So we have now 2x times the quantity of 3x plus 4. So this is now our final answer. So I only get this 3x plus 4 from here and 4 from here. Okay, next. Okay, so let's proceed to our third example. So, for example, we have 3mn cubed plus 12mn squared minus 96mn. So, you think for the greatest number that can divide 3, 12, and 96. Also, think of a variable that is common between mn cubed, mn squared, and mn. So, that is 3mn. So, since 3 can divide 3, 3 can divide 12, and 3 can divide 96, then you think, or you look for the common variable among these three terms. So, that is m and n. Then you take the lowest degree of exponent. So, since m here has the only one degree of exponent, so we have here 1 as the exponent. Then for n, we have different exponents. So we have 3, we have 2, and we have 1. So we take only the less value of exponent, which is 1. So that's why our answer here is only n. Okay, next, we divide 3mn from the given. So 3mn cubed divided by 3mn. So 3 divided by 3, that is 1. Then m divided by m, that is 1. N cubed divided by n, that is n squared. So since n cubed, I cannot write here properly. So n cubed is just equal to n times n times n. Okay, so for your n, that is only n. So we divide here n. So we take n divided by n. So the remaining n, we have here 2n, or that is n times n is n squared. Okay? So we have here n squared. Next, 12mn squared divided by 3mn. Okay, so 12 divided by 3, that is, so 12 divided by 3, that is 4. And then m divided by m, that is 1. N squared divided by n. So n squared can also be written as n times n. Next, n divided by n. So we take n divided by n. So the only remaining n is 1. So 1n. So we have here 4n. 4 times the remaining 1n. So 4 times n, that is 4n. Next, for the last, we have 96mn divided by 3mn. So 96 divided by 3, that is 32. Mn divided by mn is equal to 1. So 32 divided by 1, 32 times 1 rather is 32. So then let's copy these three answers. So we have now 3mn times the quantity of n squared plus 4n minus 32 is the factored form of our example. Okay, next. Let's proceed to factoring difference of two squares. So in factoring difference of two squares, make sure that the terms are perfect squares and the operation must be subtraction or difference. So take note that a difference of two squares are perfect squares. So what do you mean when we say perfect squares? So for example, we have 1, 4, 9, 16. So perfect squares, we can also extract their square root without any decimal point or remainder. So for example, 4. So what is the square root of 4? That is 2. Then what is the square root of 9? And that is 3. Square root of 16, that is 4. Square root of 5, that is 5. Square root of 6 is 6. So these numbers are example of perfect squares. And then take note that factoring difference of two squares, so from the title itself, difference. So the operation must always subtraction. So if it is not a subtraction, then that is not an example difference of two squares. Okay, so let's proceed to example number 1. So we have here 4x squared minus 25. Then let us check if it is a difference of two squares. So first is you take the square root of the first term and you take the square root of the last term. If you can extract their square root without any decimal, or if it comes up with a whole number, therefore, that is a perfect square, or that is a difference of two squares. So take note, the operator or the operation that we use must be subtraction. So that is already checked. Okay, then we extract the square root. So the square root for 4x squared is 2x, and the square root for 25 is 5. So therefore, the given example is a difference of two squares. Next, let's proceed to example number 2. Let us check if it is a difference of two squares. So first is we extract the square root of the first and the last term. Okay, then take note of the operator that we use. It must be minus sign. Okay, so let's take the square root of 9x squared, that is 3x. Then the square root of 1 is 1. So therefore, it is an example of difference of two squares. Next, let's proceed to our example number 3. 4x squared plus 25. So get the square root of each first and last term. So we can get the square root of the first and last term, but take note of the operation that we use. So we use addition, therefore, it is not a difference of two squares because the symbol used is addition, not a subtraction symbol. Although we can take the square root of 4x squared and 25, but the symbol we used is addition. So this is not an example of difference of two squares. Okay, now let's proceed to the general formula for the difference of two squares. So take note of the formula. So x squared minus y squared is equal to the quantity of x plus y times the quantity of x minus y. So take note of the operators or the operation that we use, the addition and subtraction. Okay, so for example, factor 9x squared minus 49y squared. So we take the square root of first and last term, so square root of, so we have here the formula. So you put first the formula so that it is easy for you to write your answers later on. Okay, so you take the square root for 9x squared, that is, or the factor of 9x squared is the same as 3x times 3x. So we plot 3x. Then you take the factors for 49y squared is also equal to 7y times 7y. So it's just equal to 49y squared. Then we plot our answer. So 3x, you put it here. then another 3x, you put it here, and then for 7y here, and another 7y, you put it here. So that's why our final answer is, or the factored form for the for the difference of two square is the quantity of 3x plus 7y times the quantity of 3x minus 7y. Okay, next, let's proceed to our example number 2. So we have here 3x squared minus 25y exponent of 4. Okay, you put first the formula, the general formula of your difference of two squares. So we have here the plus operation and then the minus operation. Okay, then let's get the factors of 36x squared and the factors of 25y exponent of 4. Okay, so for 36x squared, the factors is 6x times 6x. Then the factors for 25 y exponent of 4 is 5y squared times 5y squared. So another idea to get 6x is to take the square root of 36. Is to take the square root of 36x squared and also take the square root of 25y exponent 4. So that is another way to find 6x and 5y squared. Okay, next, let's proceed to our final answer. Okay, so you just only plot 6x from here, another 6x from here, then 5y squared, then your 5y squared. So the factored form of 36x squared minus 25y exponent of 4 is the quantity of 6x plus 5y squared times the quantity of 6x minus 5y squared. So that is our final answer. Next, let's proceed to our example number 3. Okay, so you look at first if you can take a common monomial factor from the given. So if we look at the given example, we can get a common monomial factor which is 2. Okay, so let's divide 2 from our given. So 2 divided by 18x exponent 4 times y squared, that is, so 18 divided by 2 is 9, then x exponent 4 times y squared minus, so 2 divided by 2, that is 1. Okay, so we have here now the new difference of two squares inside the parentheses. Okay, so we can now take the square root, or we cannot take the factors of our given difference of two squares. So we have here, okay, so for the factors of 9x exponent 4 times y squared equals is just equal to 3x squared times y times 3x squared times y. Okay, next is you take the factors for 1. Of course, it is just only 1 times 1 is, so that is equal to 1. Okay, then we copy our final answer from here. 3x squared times y is here, then 1 plus 1, then 3x squared minus 1. So you just copy 1 in here. So this is now the factored form of our given example. Next, factoring perfect square trinomial. When we square binomial, the product is called a perfect square trinomial. So trinomial, it is a polynomial with 3 terms. Again, a trinomial is a polynomial with 3 terms, and a binomial is a polynomial with 2 terms. Okay, to identify whether the given trinomial is a perfect square, first and last term must be a perfect square. middle term must twice the product of the first and the last factored term. So take note of this, that the middle term is twice the product of the first and the last factored term. Okay, let's have another example for that. Okay, so we have first the general formula of perfect square trinomial. So take note of this formula because we will be using this to factor out a perfect square trinomial. Okay, so let's proceed to our example number 1. Factor the trinomial 25x squared minus 10xy plus y squared. So first is to get the factor of our first term, which is our first term is 25x squared. So we get its factors, that is 25x squared is just equal to 5x times 5x. So these are the factors of our 25x squared. Next is to get the factor of our last term, which is the y squared. So the factors of y squared are y times y. And then we will plot this to our formula from the given formula earlier, that is 5x minus y. So here we get the 5x, then we get y here, 5x and y. Okay, so we can also write this in the form of the quantity of 5x minus y squared. So they are still the same. So this expression is the same. Okay, note that the middle term must be twice as the factored of the first and last term. So our twice. So 2 here is always constant because it is twice. Then 5x, we get 5x from the factored form of 25x squared. And then the factored of y squared is y. So 5x times y, that is 10x. So 10xy must equal to your middle term. Okay, next. Let's proceed to our example number 2. 3x squared minus 18xy plus 27y squared. So first is take a look if they have a common monomial factor. So get the greatest number that can divide 3, 18, and 27. Also look at their variables if the three terms have a common variable. Okay, so don't forget to put the formula so that it will be easy for you to put your answers. Okay, so our common monomial factor is only 3. So why is it that we don't get x as our variable or our common monomial factor? Since the first term and the second term has the only x and the last term don't have an x variable. Also, we don't write here y as our variable because the first term don't have a y variable, so they don't have a common variable among these three terms. Okay, so our only common monomial factor is 3. Then we get, or let's divide the common monomial factor from our given. So 3 divided by 3, that is 1. Then 3 divided by 3x squared divided by 3, that is x squared, minus, copy the sign, 3 divided by 18xy, that is 6xy, 27 divided by 3, y squared, that 27y squared divided by 3, that is 9y squared. So 27 divided by 3, that is 9. Then you copy y squared. Okay, now we can get the perfect square trinomials. Okay, so you use the formula. Okay, so factor the first term. X squared is just equal to x times x. Then you factor the last term. 9y squared is just equal to 3y times 3y. Okay, so our final answer is 3 times the quantity of x minus 3y times the quantity of x minus 3y. So also we can write this in the form of 3 times the quantity of x minus 3y squared. So it is still the same. Okay, note that note that the factor must be twice the product of your factors, or this must be equal to our middle term. So our middle term is 6xy, so that is correct. Okay, so any questions? If you have question, kindly message me or you can comment here down below. And that's all. Thank you for listening and keep safe everyone.